Hi guys, welcome back to my channel. So today we're looking at limits of accuracy, which sometimes your teachers could call it bounds, so upper and lower bounds. Okay, so we're just going to jump straight into it, but please like, share and subscribe this video. Kindly help my channel to grow. Thank you very much. The number 79 has been rounded to the nearest unit. Find its lower and upper bounds. So whenever you get a question like this, basically what they're saying is this 79 that you're looking at is not the actual number, okay? So it's a particular number has been rounded to give you 79, right? Now, what is the possible range? Okay, so what's the highest possible number that you can round to give you 79? That's the upper bound. And what's the lowest possible number that you can round to give you 79? And that's your lower bound. Okay, so looking at that, now for example, if you are familiar with your rounding, okay, you would know that when it is five or more, you're rounding up, and when it's less than 5, you're rounding down. Okay, so if we're going to round to make 79, right, now because it's saying to the nearest unit, now this is also another important thing to be aware of, the nearest unit. So the unit, so in this case, this is your unit, this is your tens, right? Tens meaning 10, 20, 30, 40, 50, 60, 70 in this case. And then your unit is just your 1, 2, 3, 4, 5, 6, 7, 8, 9. So unit numbers. So a number that is rounded to your nearest unit, that means that you must have had a decimal. So something less than 1. Because the smallest unit you can have is 1, right? Okay. So to go up, the upper bound will be, you divide that 1 by 2, right? That gives you 0.5. Okay, so your upper bound is adding 0.5, or your lower bound will be subtracting 0.5. Okay, because 1 is the smallest unit you can get. All right, so to round this 0.5 now to this to units, so if you round it to the nearest unit, you get 1. Okay, now if we then translate this into our 79, okay, so to get the upper bound, right, we are subtracting, sorry, to get the upper bound, we are adding 0.5, and to get the lower bound, we are subtracting 0.5. Okay, so which means that our upper bound will be 79.5 and the lower bound will be 78.5. Okay, now when you then think about this, okay, so numbers that are less than 79.5 can be rounded to make 79, right? So for example, I'm just going to do a quick one here. If we were to round 79.4, okay, to the nearest unit, right, it will give us 79. If we were to round 79.3 to the nearest unit, it will give us 79. All right, but of course, if we were to round 79.5, it will give us 80. But that's not what we want. So that means that we want numbers that are less than 70. So it could be any number less than 79.5, right? However, the number will be greater than 78.5, because if we round 78.5, it will give us 79. If we round 78.6, it will give us 79. But if we round 78.4, it won't give us 79, it will give us 78. Okay, so that means that your 79, so numbers that are less than 79.5 but greater than or equal to 78.5. Okay, so hopefully that makes sense. We're going to move on to question 2, and I'm going to go over all of that again. Question 2 says, oh, by the way, what I've written here is your final answer, okay? So 78.5 is less than or equal to 79, which is less than 79.5. Okay, so let's do this. The number 10 has been rounded to the nearest whole number. Okay, find its lower and upper bounds. So again, the nearest whole number. So we can have numbers like, let's say, 10.9, 10.3. These are not whole numbers. These are decimal numbers, okay, because it has that decimal points there, right? But if I were to write down 10 or 11, these 10 and 11 are whole numbers. As long as it doesn't have a decimal or it's not in a fraction, then it's a whole number, okay? Now they said that the number 10 has been rounded to the nearest whole number. Now, what do they mean by the word nearest whole number? So if I have 13.736, okay, this is not a whole number, okay? That's because I've got this decimal point and the numbers going on after that. Now, the nearest whole number, so this is a decimal number, but when I get to here, that's my first whole number. So that's the one that is nearest to the decimal, okay? So the nearest whole number. So what it means is that you want to round all of this until you don't have a decimal number. This is your nearest whole number, which brings us to, or should I say, this is another way of them saying that they round it to the nearest unit or nearest whole number, okay? So with that being said, we're now going to go ahead to answer the question. Okay. So nearest whole number is the same thing as saying the nearest unit. So we're using the same method as before. Nearest unit, the smallest unit you can have is 1, right? So upper bound means that you split that nearest unit. So that 1 is split into 2 parts. So divided by 2, you get 0.5, 0.5. So that means that you add or you subtract, okay, 0.5. Now, because we are dealing with 10, okay, so the upper bound for that 10 will be that you're adding 0.5, and the lower bound will be that you're subtracting 0.5. So that then means that our upper bound is 10.5, because we have 10 plus 0.5, and our lower bound will be 10 minus 0.5, and that gives us 9.5. Okay, now we know that, so I'm going to put my 10 here because that's the 10. We know that only numbers that are less than 10.5 that can be rounded to the whole number 10. Okay, so 10.5, if you were to round that to the nearest whole number, it will give you 11. Because of the rule of rounding, 5 or more will round up. So to make this 10 to become 11. But if we have 10.4, 10.3, 10.2, 10.1, those will round down to 10. Okay, so that means that we need numbers that are less than 10.5. Those are the only ones that can round to give you 10. Right? Now, 9.4 will round to give you 9. 9.3 will round down to give you 9. But you need numbers that are 9.5 and above. So 9.5 will round up to make 10. 9.6 will round up to make 10. So that means that you need numbers, right, that are above 9.4. So equal to, okay, so 9.5 or above 9.5. So that means that it has to be less than, so 9.5 is less than or equal to 10. So anything in between that 9.5 and 10 will round to give you 10. Okay, so having made that explanation, I'm just going to jump through the rest of the questions without that intense explanation. But I would advise that you listen to the end of the video because you could get more information that would help. So this here is our answer. The number 16 has been rounded to the nearest integer. So again, it means the same thing. So calling it the nearest unit, calling it the nearest whole number, calling it the nearest integer is another way of referring to the same thing. Okay, so if 16 has been rounded to the nearest whole number, so like we said, when you're dealing with nearest whole number or nearest unit or nearest integer in this case, that means that 1 is the smallest integer that you can get. So divide that by 2. So you have 0 0.5, 0 0.5. So you just get your 16. In this case, we're dealing with 16. So plus for upper bound 0 0.5 minus for lower bound 0 0.5. So 16 plus 0 0.5 we give 16.5. 16 minus 0 0.5 will give you 15.5. Okay, so the way you then refer to this will be, so you write down your 16. We know that it has to be numbers that are less than 16.5. So you put your less than sign here, 16.5. But no, the number that is equal to this or a bit more, so less than or equal to 16. So 15.5 will be here. So this is your answer. Okay, on to number 4. The number 1000 has been rounded to the nearest 100. Find its lower and upper bound. I love this one, fantastic. Now here, they didn't say nearest integer or nearest whole number or nearest unit. You're dealing with nearest 100. So you always want to know what your rounding is to, and then that helps you to find your upper and lower bound. So if we're rounding to nearest 100, we're going to do the exact same thing that we done here and here with the 1, right? So because it's nearest 100, you take your 100, because 100 is the smallest 100 you can get. So hundreds are 100, 200, 300, 400, 500, okay? So the nearest 100 is just 100. That's the smallest of the hundreds value that you can get. So you split that into 2 parts, okay? So 100 divided by 2 is 50. So your upper bound is you adding 50. Your lower bound is you subtracting 50. Okay, now we take those upper and lower bounds, bring them in to the number you're working with here, which is 1000. So I'm going to say 1000. Okay, finding the upper bound means that you add 50. To find the lower bound, you subtract 50. So 1000 adding 50 is 1050. 1000 subtracting 50 is 950. Okay, so our answer then is, you get the question you've been given, which is the 1000. Okay, so 1050, 1000 is less than 1050, and then 950, so less than or equal to okay. So that there is our answer, or how you would write it down. Okay. Now moving on to question 5. The number 9000 has been rounded to the nearest 1000. Okay, so again here our nearest is 1000. So you grab that 1000, you split it into your bounds. So you want to split it into 2 parts. So half of that is 500 for your upper bound. Sorry, I was just about to write 5,000 there. That's not right. Okay, so 500 for your upper bound, and you need to subtract 500 for your lower bound. So with that now, the number we're working with is 9000. That's a number that has been rounded. So to get the upper bound, you add the 500. To get the lower bound, you subtract the 500. So 9000 minus, 9000 plus 500 will be 9500, and 9000 subtract 500 will be 8500. So to represent that then, so sometimes you could represent it using the number, so 900, right? 9,000 that we've been given, or you can put down x. Sometimes you can put it down as x. So in fact, I'm going to introduce using x here. So using x, you write down the numbers that you have, 9,500, and this one less than or equal to 8,500. Okay. Number 6. The number 1,000 has been rounded to the nearest 100. So again, here we're dealing with nearest 100, and we want to find its lower and upper bounds. So you take the nearest 100. So the first thing you always need to know, I've said this repeatedly and I can't stress it enough, nearest 100. So your nearest first is what you deal with. Okay, so you split that into two parts. Get your upper bound, half of the 100 is 50. Get your lower bound, half 50. Now the number that you're working with is 1,000. So now you can find your upper and lower bound. So you add 50, here you subtract 50. So for the upper bound, 1,000 plus 50 is 1,050, and 1,000 minus 50 is 950. And then we can represent our value here. So x is less than 1,050, but x is greater than or equal to 950. Okay. Moving on to question 7. The number 51.2. I love this one. It's one of those ones with the decimal coming in. The number 51.2 has been rounded to the nearest one decimal place. So again, we want to picture that first, one decimal place. Now, the smallest one decimal place that you can get. In fact, first of all, what is decimal place? So it's basically looking at your place value, right? So I'm just going to do a quick recap on decimal place here. So let's say you have 369.345 and you're asked to indicate the decimal places, to indicate the place value. So we know that, so if I were to cover that decimal there, okay, this is your unit, or some people will call it ones, or your units. So that's your unit there. This is your tens and this is hundreds, right? So that's heading in that direction. It's increasing as you go up. So units, tens, hundreds. Now, when there's a decimal point, right? So this one is your tenth. So by tenth, T-E-N-T-H for this one. This is your hundredth with a T-H. This is your thousandth with a T-H, right? But the first number after this decimal point is your one decimal place, 1 dp. The second number after this decimal point, so 1, 2, this is your 2 dp, your 2 decimal place. 1, 2, 3, 3 decimal place. So that's the location or the spot after the decimal point, right? Now, if this number has been rounded to one decimal place, it follows the same procedure. So do not let the decimal freak you out. We are following the same procedure as what we've done in question 1 to 7. So now I'm going to rub this off. When you're dealing with one decimal place, right, the smallest one decimal place that you can get is 0.1. Okay. So the same way when I said earlier, the smallest units that you can get, because your units are 1, 2, 3, 4, 5, 6, 7, 8, 9, and the smallest is 1. Okay. When it comes to tens, your tens are 10, 20, 30, 40, 50, 60. The smallest tens that you can get is 10. The smallest hundreds that you can get is 100, because you have 100, 200, 300, 400. So same thing with decimal, right? You can have 0.1, 0.2, 0.3, 0.4, 0.5, and so on. But the smallest one decimal place you can get is 0.1. Okay, so we're going to take 0.1 because we are working with the nearest one decimal place. Now you split that 0.1 into two parts, same as before. the upper bound will be that you're adding 0.05. The lower bound will be that you're subtracting 0.05. So if you're wondering how I got 0.05, 0.1 divided by 2 or split into two equal parts will be 0.05 and 0.05. Okay, now the number that we're working with here is 51.2. So you take your 51.2, find its upper bound, and to find its lower bound, we're just adding 0.05 and subtracting 0.05. So now we need to do 51.2 plus 0.05. That will be 51.25. And then 51.2 minus 0.05 will be equal to 51.15. Okay, and then now we can write down our values. So the bigger one comes here, 1.25, and the smaller one less than or equal to, and we put that here. Okay, so that's our answer, and that's our answer for that one, and that's our answer for that one. Okay, so question 8. The number 43.4 has been rounded to the nearest tenth. Okay, so this is very similar to what I explained earlier when I put the number. So the very first number immediately after the decimal point, so to the right hand side of the decimal point, that's the tenth with a th. Okay, and that is also the one decimal place. Okay, so this nearest tenth is the same principle as the one decimal place. They both mean the same thing. Okay, so this is just similar to how when we answered question 1, 2, and 3, they referred to unit as whole number, as integer, is all the same thing. So here, decimal place or nearest tenth means the same thing. So you just get your 0.1, that's the smallest tenth that you can get, and then split that into 2 to get your upper and lower bounds, and that gives us 0.05. And then we're dealing with 43.4, so we get the upper and the lower bound, add 0.05 and subtract 0.05, so which is equal to, this then becomes 43.45, and this becomes 43.35. So to write down our answer, okay, so the bigger one, which is that there, comes here because that one is greater than. So, and then it's less than or equal to, so the smaller one comes down to the end there. And that's the answer. So on to the last question, question 9. So question 9, the number 22.4 has been rounded to the nearest one decimal place. Find its lower and upper bound. So again, we're doing the same thing as before. So we've got one decimal place, so 0.1 is the smallest one decimal place you can get, and split it into your upper and lower bounds. Now the number we're working with is 22.4, so you get that down here, and then get its upper and lower bound by adding 0.05 and subtracting 0.05. So this here gives us 22.45, and this here gives us 22.35, and we just put our answer down here. So the larger number, 22.45, because it's larger than 22.4, and the smaller number, so less than or equal to 22.35. Right, that brings us to the end of this worksheet, which is going to be the first one on the limits of accuracy. Thanks for watching this. If you manage to get to the end of this video, please leave a question at the box suggesting a topic that I can do, and I promise you I'm reading the messages and I definitely will treat the topic. Bye.